Hello everyone. In this video, we are going to discuss about a previous year JEE question from the chapter Electrostatic Potential and Capacitance of class 12 physics. See, the question is combination of two identical capacitors, a resistor R and a DC voltage source of voltage 6 volt is used in an experiment on RC circuit. It is found that for a parallel combination of capacitor, the time in which the voltage of the fully charged combination reduces to half its original value is 10 seconds. For series combination, the time needed for reducing the voltage of the fully charged series combination by half is ABCD. 4 options are there. You see, it is a question asked in the year of 2011. So you see, in this question, we have two identical capacitors. Identical capacitors means, suppose I am taking one capacitor here of capacitance C, then the second one is also having the same capacitance C. Okay, now there is a resistor of resistance R and a DC voltage source 6 volt is used in this experiment. It is an RC circuit, and you see, when these two capacitors are connected in parallel, okay, these two capacitors are in parallel combination and it is connected to a resistor. Okay, it is connected to a resistor as well, then to a DC voltage source. And it is found that when these two capacitors are in parallel combination, then the time in which the voltage of the fully charged combination reduces to half its original value is 10 seconds. That is actually given. Now, when these two are connected in series combination, then what will be the time needed for reducing the voltage of the fully charged series combination by half? That is what we want to find out. So, you see, for an RC circuit, during charging, the voltage across a capacitor at any instant t is given by this equation V equals V0 into 1 minus e raised to minus t by RC. Okay, where V is the voltage across the capacitor at any instant t. Okay, R is the resistance and C is the capacitance. V0, that is the original voltage of the combination or that circuit. And it is given in the question that in both the combination at different instants of time t, the original the voltage across the capacitor that actually reduces to half its original value. That is, V becomes V0 by 2 at a particular instant of time t. So we can write V0 by 2 equals V0 into 1 minus e raised to minus t by RC. Okay, this V0 cancelled. So that we can write 1 by 2 equals 1 minus e raised to minus t by RC. Now, I am going to take this minus e raised to minus t by RC to this side of the equation and 1 by 2 to this side of the equation. So that it becomes minus e raised to minus t by RC becomes plus e raised to minus t by RC equals 1. I am taking this 1 by 2 to the other side of the equation so that it becomes minus 1 by 2. So 1 minus 1 by 2. See, 1 minus 1 by 2 is 1 by 2. So e raised to minus t by RC is equal to 1 by 2. This e raised to minus t by RC can be written as 1 by e raised to t by RC. This is equal to 1 by 2. So from this we can write e raised to t by RC. This is equal to 2. Now, if e raised to t by RC is equal to 2, what about t by RC? This will be equal to log 2. From this, we can write the time t is equal to. T is the time for half voltage. That is time for half voltage in grouping or combination of capacitors. It can be the series combination or it can be the parallel combination. So, t is equal to RC into log 2. Okay. Now, if we consider the parallel combination of the two capacitors of capacitance C. See, we know that for parallel combination, the effective capacitance is having this form C1 plus C2. Here, both the capacitors are identical, so their capacitances are the same. So, we can write C plus C, okay, which is equal to 2C. Then, we have the time for half voltage in the combination of the capacitors as T equals RC into log 2. So, time for half voltage in parallel combination of capacitors can be written as TP. So, TP is equal to R into CP, where CP is the equivalent resistance in the parallel combination. Then log 2. Okay, I am taking this as equation number 1. Now you see, in series combination, we know that the effective capacitance is having this form 1 by Cs is equal to 1 by C1 plus 1 by C2. Here both the capacitors are identical. So both the capacitors are having the same capacitance. So we can write 1 by C plus 1 by C. This is actually equal to 2 by C. Okay, then Cs, which is the equivalent capacitance in the series combination, this will be equal to C by 2. Alright, now the time for using this formula, the time for half voltage in series combination or series grouping can be written as Ts is equal to R into effective capacitance in the series combination into log 2. I am taking this as equation number 2. So you see, equation number 1 gives the expression for the time for half voltage in parallel combination, and equation number 2 gives the expression for the time for half voltage in series combination. I am considering this equation number 2, which is Ts is equal to R into Cs into log 2. What I am doing is, I am just multiplying the numerator and denominator of this expression with 2. Okay. So this becomes what? R into what is Cs? Cs is C by 2. C by 2 log 2 into 2 divided by 2. Okay, now you see this 2RC log 2 is what? 2RC log 2. It is what? You see here we have TP equals RCP log 2. Okay, this can be written as what? R into what is CP? 2C. So 2RC log 2. So you see 2RC log 2, 2RC log 2, it is actually TP. So we can write TS is equal to TP divided by 4. Now what is TP? It is the time for half voltage in parallel combination. And it is given in the question that in parallel combination, the voltage reduces to half of its original value in 10 seconds. So TP is actually the time for half voltage in a parallel combination, and it is given in the question as 10 seconds. So 10 seconds divided by 4. Okay, so we get Ts is equal to 10 by 4, which is actually 5 by 2, which is 2.5 seconds. So where Ts is the time for half voltage in series combination. Okay, so you see which option is the correct option? So option D, 2.5 seconds is the correct option. So I hope it is clear to you. You will get all other questions asked from the same chapter for the previous JEE exams from the playlist of this channel. Thank you.